All right, let's walk through some equations that are introduced in Chapter 2. We introduced them in Chapter 2. We're going to use them throughout the course. They apply to one-dimensional motion, certainly, but they also apply to two-dimensional and three-dimensional motion. We're not going to do three dimensions, but certainly we'll do two dimensions. So these are really the cornerstone equations for the bulk of this class. And we start off with the definition of displacement. Displacement, which is delta x, is simply the difference between the final position and the initial position. So delta x is x final minus x initial. One note here, I'm not going to show you how to use these equations in this walkthrough. I'm just introducing them, just to familiarize you with what we're going to be talking about. We'll work through problems at other times. I'll show you how to use them. But these are equations that are going to be on the equation sheet. You're going to use them in many different kinds of problems. Okay, so displacement is the final position minus the initial position. Velocity is the displacement over time. It is the time rate of change of displacement. And acceleration is the time rate of change of velocity. So it's velocity over time. All right. So those are really the fundamental quantities that we need to understand. What I want to start with in this presentation is taking a deeper look at this equation right here. So I've got average velocity is displacement over time. So there it is. And what I'm going to do is just some simple algebra. I'm going to take this t term and I'm going to move it to the other side. So I'm going to express this, basically solve this for delta x for displacement. And I'm going to drop the delta because that's what we do. We just drop the delta t. It's not super important on the delta t. All right. So we have this equation now for delta x that's expressing it in terms of velocity and time. This is our old friend distance equals rate times time. It's an equation that you guys probably saw in middle school. Well, there it is again. What I want to explore now is what exactly does this mean? It says V average. When you want to find the average value of something, you know, if you have a group of numbers and you want to find the average, you add all those numbers together and you divide by however many numbers you have. So if you have two numbers, let's say you had a 3 and a 5 and you wanted to find the average of them, you simply add 3 and 5, divide by 2, that's 8 over 2. Is 4. So the average of 3 and 5 is 4. So in the case of V average, if I had an initial velocity and I had a final velocity, if I wanted to find the average of those two, I would add them and I would divide by 2, right? That's all I'm doing. So delta x is V sub average, which is this right here, times time. And there it is right there. So instead of dividing by 2, I'm multiplying by 1/2, but that is an equation. That is on the equation sheet, that it's giving me the displacement in terms of initial velocity, final velocity, and time. So displacement is 1/2 initial velocity plus final velocity times time. And every time you see that, just remember that is the average velocity. That's all that is. It's a fancy way of saying average velocity. All right. So now let's take a look at that third equation that was on the first section that I introduced there. This average acceleration. So average acceleration is the change in velocity over time. All right, so change in velocity. So anytime you have a delta anything, we saw it with displacement. So remember that delta x is x final minus x initial. Well, similarly, delta v is v final minus v initial. So your average, your acceleration is your delta v, vf minus vi over t. And again, I dropped that delta t. All right. So just doing some rearranging algebraically, right? So I'm just taking this t and I'm moving it to the other side. So I've got now vf minus vi equals at. I'm going to do just a little bit more algebra. I'm going to take this vi, I'm going to move it to the other side. So I should end up with something that says vf equals vi plus at. And if I did everything right, there it is. Boom. Okay. Again, this is an equation that is on the equation sheet. We actually say that this equation is definition of acceleration. It doesn't look like a definition of acceleration. Actually, this looks more like the definition of acceleration, but this is the equation that we use, and it is equivalent. I mean, we just did some very simple algebra to get from the top line to the bottom line, so we call that equation the definition of acceleration. Again, something that's on the equation sheet, something you're going to use all the time. It is expressing the final velocity in terms of initial velocity, acceleration, and time. It could be that you have final velocity and you are trying to find the initial velocity, or maybe you're trying to find the time and you have initial velocity. Just because the final velocity is on the left-hand side here doesn't mean that that's the only thing that you can use this equation for. Remember, you can use algebra, or you're going to use algebra to find all kinds of different things. But final velocity, initial velocity, acceleration, time, there you go. Definition of acceleration is the equation that we're going to use. All right. Now, what if I take those two things that I just figured out into some light derivation? I take the definition of acceleration, and I take this this distance equals rate times time, this average rate, and I start combining them, right? So if I take, I've got VF here, and I've got this expression for VF. So if I take that and I put that in there, what does that end up with? So I get this delta x is 1/2 VI plus this part here. So that's that. So VI plus AT all times t. And if I want to just do a little bit more algebra on here, right? So I end up with 1/2 2VI plus AT times t, right? So I'm just adding those two. And there it is right there. Now, what do I want to do? I want to go ahead and just multiply this out, right? So I'm going to multiply this part that's in the inside of the parentheses by 1/2 t, and what I get is, so the 1/2 and times 2 is just leaves me with v sub I times t, VIT, and then 1/2 AT squared. This is a very important equation. We're going to use this all the time. We call this the displacement curve. Displacement because there's displacement. Curve, I guess curve because we've got this t squared term. This is a quadratic equation, and it does describe a parabola, usually, depending on the circumstance. But yeah, displacement curve, there it is. Very important. You're going to see that a lot. All right. What's next? All right, so this was an equation that we were messing around with. We just did a little bit of light derivation to get this VF equals VI plus AT. What do we want to do with that? We're going to square it. So let me go ahead and, I'd forgotten what we were going to do. So what I want to do is just square this. Now why, I don't know. I do know why, because we're trying to get somewhere else. All right, so VF squared, I'm just going to take VI plus AT, multiply by itself. Remember the whole FOIL, F-O-I-L, first, outer, inner, last. So we do VI times VI is VI squared. We get the outer A squared times T squared. Inner terms, actually that wasn't the outer term, was it? Outer terms are this guy and this guy. So we get VIAT. And then the inner terms are also, it's VIAT. And then this guy is AT squared. There it is. Okay, and then when we simplify that, we get VI squared plus 2VIAT plus A squared T squared. And that's VF squared. All right, so there it is. Oops. There it is in little neater. Okay, now what we want to do is we're trying to get to a place, and I know where we're trying to get, but you have to kind of see it. So what I'm going to do here is I'm going to factor out on the right hand side. I'm going to factor out a 2 and an A out of these terms, out of these two terms. So that leaves me with, so I factor out this 2, so I'm left with a VI and a T. So this first term is 2A times VIT. You can kind of see that there. All right, the second term might be a little trickier to see. I'm factoring a 2, but there's no coefficient. So to factor the 2, I'm left with a 1/2. 2 times 1/2 is 1, because that's what that is. It's a 1. All right, I pull out an A, so I'm left with just one A. You had an A squared, but now I just have an A. And I don't do anything with the T, so the T squared lives there. Okay. Remember, well, so there we go. I factored out the 2A, and that should be what lives there. Okay. This should look familiar. We just saw this a second ago. That is the displacement curve. So what I'm left with here is VF squared equals VI squared plus 2A, and the displacement curve says that delta x is VIT plus 1/2 AT squared. So this part right here is just delta x. It's just the displacement. There it is. VF squared equals VI squared plus 2A delta x. I don't know the name of that equation. It's very handy. It gives, really, because it has the displacement, it doesn't have any dependence on time, just initial velocity, final velocity, acceleration. It's a very handy equation. It deserves a name. Maybe it has one. I just don't know what it is. Okay, so here they are in all their glory. These are the equations that are on the equation sheet that you're going to use to solve your problems. You will get familiar with them, I hope, and so we will work problems with these over the coming weeks. Just wanted you to know where they were coming from. It is an important note. You're not going to be required to know how to derive these equations. I just want you to understand that they do come from those initial concepts, right? There's no magic here. All these equations are just derived very simply from those initial concepts. You do not have to you don't have to know how to derive the equations yourself. All right, thanks for watching.